In this video, we're going to talk about the rest of the functional groups in this chapter. In particular, we're going to talk about alcohols, amines, halides, the different types of carbonyls such as aldehydes, ketones, and carboxylic acids, and then finally end it with a brief discussion of what a polymer is. So an alcohol are distinctive organic compounds that have a functional group that looks like an OH. So any compound or any organic compound that has the OH group on it is considered to be an alcohol. So for example, a very common alcohol is ethanol. So ethanol, if we look at the name ethanol, it's ethanol. All alcohols end in the suffix ol, and then we have this prefix eth, which stands for two carbons, and so this is a two-carbon alcohol with an OH attached to it. And so this right here is what the formula for ethanol would look like. Two other popular alcohols that you're probably familiar with is propanol and isopropyl alcohol. So propanol, as the name suggests, is an alcohol because it has an OL at the end, and then the prefix has pro in it, which means three. So this is a three-carbon alcohol with an OH. Now, we have two places that we could put that OH. We could put the OH at the end or in the middle. And so if we put it on the end carbon, it becomes what we call normal propanol. And these all should have hydrogen at the end or on the carbons. Remember, carbon has to have four bonds. And so we're going to put hydrogen to make sure that all the carbons have four bonds. The other option for that OH group is on the middle carbon. And so we could also have that OH, and in this instance, this alcohol is what we call isopropyl alcohol, which you are familiar with as rubbing alcohol. So notice these are alcohols, they all have an OH. And right here on the center carbon, here's on the end carbon, and then here's ethanol for that one carbon. The next functional group that I want to talk about is what's called an amine. Now, amines are very simple to find and to locate, and simply they just are nitrogen containing compounds. So if your organic compound has a nitrogen, it is most likely an amine. Now, there are other functional groups that have nitrogen in it as well, but for right now we're just looking at the simplest organic compounds that contain nitrogen, which would be an amine. One example of an amine would be methylamine, which is basically carbon and a nitrogen with two hydrogens attached. And amines can be all kinds of different combinations. These do not have to be hydrogens attached to the nitrogen. It could be other chains, long chains of carbons, or some other functional group like oxygen or something like that. So one example would be, we could maybe have three carbon groups on this, where each one of these is a hydrogen. And so this right here would be another amine. So amines are simply organic compounds that have a nitrogen associated with them. The next type of functional group is what we would call an alkyl halide. Alkyl halides are simply long chain or hydrocarbons that have a halogen attached to it. So a common simple alkyl halide would be methyl chloride, where we have this methyl group. So you remember meth means one carbon, so this is a methyl, and we have the chlorine attached to it. So whenever we have a halogen attached to a chain of carbons, we would call this an alkyl halide. Now the next major group of functional groups are carbonyl groups. And a carbonyl group is signified by a carbon-oxygen double bond. So whenever you have a COO, you have what we call a carbonyl. And there are many different types of carbonyls. So if this C double bond O is at the end of a long chain of carbon, so let's just say we have a 3-carbon chain and we put our double bond oxygen on the end carbon, this is what we would call an aldehyde. If the double bond oxygen is on the end carbon, it is an aldehyde. If that carbon double bond oxygen is on the middle carbon, like this is what we would call a ketone. So the way we distinguish these two carbonyls is where the location is for the C double bond O. If the C double bond O is on the end of the chain, it is an aldehyde. If it's in the middle of the chain, it is a ketone. The next type of carbonyl that is very common is what we call a carboxylic acid. A carboxylic acid has a group of C double bond O, it's a carbonyl, and attached to this carbon that's attached to the double bond, there's also an OH group. So what this looks like is kind of like an aldehyde and an alcohol that's combined together. So this molecule right here, if we have another carbon group, a CH3 group attached, this right here is what we would call acetic acid, otherwise known as vinegar. So this is a vinegar that you would put on your salads, is a carboxylic acid. And so the way we distinguish carboxylic acids from all other compounds is this C double bond O, and then we also have an OH attached to it. Now, there can be many different functional groups on the same carbon chain. Organic molecule does not just have to have one functional group. It can have multiple functional groups. So for example, we could have a ketone with a halogen attached to it. And so there would be hydrogens surrounding this to fulfill the 4 bonds for carbon. But this would be a ketone and an alkyl halide combined together. So there does not need to just be one functional group. There can be multiple functional groups on one compound. The very last thing I want to talk about are what is something called polymers. And polymers are probably the most useful organic compounds that we come across. Polymers involve lots of medicines and plastics. They make up our bodies. That's what DNA is. A DNA molecule is a polymer. And a polymer is simply made up of repeating units of the same thing. And that same thing is what we call a monomer. And so whenever you have a repeating unit of the same thing going over and over and over again, that is what we call a polymer. Because remember, the prefix poly means many. So we have many repeating units for polymers.